A block of mass 3 kilograms is pushed up against a wall by a force P that makes a 50-degree angle with the horizontal as shown in figure 46. The coefficient of static friction between the block and the wall is 0.25. Determine the possible values for the magnitude of P that allow the block to remain stationary. This is chapter 5, number 46. For the given, we have mass is 3.00 kilograms, the angle is 50 degrees, and the coefficient of static friction is 0.25. We have to find force in P max and P minimum. Alright, to find the maximum force, we have 4 smaller forces working on the block. We have the normal force as the wall pushing to the left. We have friction pointing down, gravity as mg pointing down, and P at an angle of 50 degrees to the horizontal. The sum of all the forces in the x direction equals 0. So P cosine theta minus n equals 0. The force of friction is mu sub s times the normal force. So friction equals mu sub s P cosine 50 degrees. So we combine these equations to get friction equal to the static of friction, the coefficient of friction, which is 0.25 times cosine of 50 times P. So for friction, we get 0.161 P. The sum of all the forces in the y direction also equals 0. So P sine theta minus friction minus mg equals 0. So if you plug in all your values, you get P sine 50 degrees minus 0.161 P, which is friction as we found earlier, minus 3 kilograms times 9.8 meters per second squared. So you combine all those and you get P max as 48.6 newtons. So to find the minimum force, all of the forces are exactly the same as before, except friction is pointing up. So just like before, all of the forces in the y direction equals 0, except this time it's P sine theta plus the friction minus mg equals 0. So plug in all your values again, you get P sine 50 degrees equals 0.161 P minus 3 kilograms times 9.8 meters per second equals 0. And you get as P minimum 31.7 newtons.